So, removing entries from the ARP table. For each devices, an ARP cache timer removes ARP entries that have not been used for a specified period of time. The times differ depending on the device operating system. So the ARP table. On a Cisco router, the show IP ARP command is used to display the ARP table. On a Windows 7, the ARPA command is used to display the ARP table. The ARP broadcast. As a broadcast frame, an ARP request is received and processed by every device on the local network. On a typical business network, this broadcast would probably have minimal impact to the network performance. The ARP spoofing. In some cases, the use of ARP can lead to potential security risks, known as the ARP spoofing or the ARP poisoning. This is a technique used by an attacker to reply on an ARP request for an IPv4 address belonging to another devices, such as default gateway, and the attacker sends the ARP reply with its own MAC address. The receiver of the ARP reply will add the wrong MAC address to its ARP table and send these packets to the attacker. So that's all for this chapter number 5, and thank you. While the source MAC address is the MAC address on the sender's Ethernet and IC. To determine the destination MAC address, the device uses ARP or provide the two basic functions, the resolving IPv4 address to MAC addresses and maintaining a table of mappings. On the ARP function, when a packet is sent into the data link layer, to be encapsulated into the internet frame, the device refers to the table in its memory to find the MAC address that is mapped to the IPv4 address. The ARP function. So hi guys, I'm back with a new video, and for this video we're going to talk about the chapter 5. This is the summary of this chapter, so let's proceed. So this chapter 5 entitled the Ethernet. So the Ethernet frame. The Ethernet is now a predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet encapsulation. Ethernet is the most widely used LAN technology today. Ethernet operates in the data link layer and the physical layer. It is the family of networking technologies that are defined in IEEE 802.2 and the 802.3 standards. Ethernet supports the data bandwidths of the 10 and 100 Mbps, the 1000 Mbps or the 1 GB per second, the 10,000 Mbps, the 10 GB per second, 40 GB per second, and the 100 GB per second. The MAC sub-layer. So, the Ethernet MAC sub-layer has two primary responsibilities, which is the data encapsulation and the media access control. The Ethernet evolution. Since the creation of the Ethernet in the 1973, standards have evolved for specifying faster and more flexible versions of the technology. The ability for Ethernet to improve over time is one of the main reasons it has become so popular. The Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence of or the FCS field. MAC address and the hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits, 4 bits per hexadecimal digit. MAC address, Ethernet identity. In Ethernet, every network device is connected to the same shared media Ethernet. Was once predominantly a half-duplex topology using a multi-access or later Ethernet hubs. This meant that all nodes would receive every frame transmitted to prevent the excessive overhead involved in the processing of every frame. MAC addresses were created to identify the actual source and the destination. The frame processing. The MAC address is often referred as the burned-in address or the BIA because historically, this address is burned into ROM, the read-only memory, and the NIC. This means that the address is encoded into the ROM chip permanently. MAC address representation. In a window host, the ipconfig, all command can be used to identify the MAC address of an Ethernet adapter. Notice that the display indicates the physical address MAC of the computer to be 00/18/DE/DD/A7/B2. If you have access, you may wish to try this on your own computer. On a Mac or Linux host, the ifconfig command is used. The unicast MAC address. In Ethernet, different MAC addresses are used for layer 2 unicast, broadcast, and multicast communication. Unicast MAC address is unique address used when a frame is sent from a single transmitting device to a single destination device. The broadcast MAC address. Broadcast packet contains the destination IPv4 address that has all ones in host portion. This numbering in the address means all of the hosts on the local network will receive the packet. Many protocols such as DHCP and ARP use broadcast. The multicast MAC address. Multicast address allows a source device to send a packet to a group of devices. Devices that belongs to multicast group are assigned a multicast group IP address. So, the MAC address table for the switch fundamental. A layer 2 Ethernet switch uses MAC address to make forwarding decision. It is completely unaware of the protocol being carried in the data portion of the frame, such as the IPv4 packet. The switch makes its forwarding decision based only on the layer 2 Ethernet MAC addresses. The learning MAC address. The switching dynamically builds the MAC address table by examining the source MAC address of the frames received on the port. The switch forwards frames by searching for a match between the destination MAC address in the frame and an entry in the MAC address table. Filtering frames. Switch receive frames from different devices. It is able to populate its MAC address table by examining the source MAC address of every frame. When the switch MAC address table contains the destination MAC address, it is able to filter the frame and forward out a single port. Switch forwarding method. Frame forwarding method on Cisco switches. Switches use one of the following forwarding method for switching data between network ports. The store and forward switching and the cut-through switching. Cut-through switching. In a cut-through switching, the switch acts upon the data as soon as it's received, even if the transmission is not complete. The switch buffers just enough to the frame to read the destination MAC address so that it can determine to which port to forward the data. The memory buffering on switches. An Ethernet switch may use a buffering technique to store frames before forwarding them. Buffering may also be used when the destination port is busy due to congestion and the switches stores the frame until it can be transmitted. Duplex and speed setting. Two of the most basic settings on the switch are the bandwidth and the duplex. For each individual switch, it is critical that the duplex and the bandwidth setting match between the switch port and the connected devices, such as the computer or another switch. The auto MDIX. In addition to having the correct duplex setting, it is also necessary to have the correct cable type defined for each port. Connection between specific devices, such as switch to switch, switch to router, switch to host, and router to host devices. Ones that require the user-specific cable types, the crossover or the straight-through. Most switches now support the MDIX Auto Interface Configuration command in the CLI to enable the automatic medium independent interface crossover. The destination on the same network. There are two primary addresses assigned to the device on an Ethernet LAN. It is the physical address, the MAC address, where it is used for Ethernet NIC to Ethernet NIC communication on the same network, and the logical address, which is the IP address. It is used to send the packet from the original source to the final destination. The destination remote network. When the destination IP address is on the remote network, the destination MAC address will be the address of the host default gateway. The router's NIC as shown is using a portal analogy. This would be similar to person taking a letter to their local post office. So the ARP. Introduction to ARP. Recall that every devices with an IP address on the internet network also has the Ethernet MAC address. When a device sends an Ethernet frame, it contains these two addresses, the destination MAC address and the source MAC address. For the destination MAC address, the Ethernet NIC, which will be either the MAC address of the final destination